Welcome to The Climate Question from the BBC World Service. We're your guide to the burning issue of our time. I'm Greer Jackson.
And I'm Neil Rozelle. Where are you this week, Greer?
Well, I'm sandwiched between a concrete factory and a construction site, as you might be able to hear behind me. They look like they're drilling into the ground, inserting lots of pipework, ready for, I don't know what, a new building, it looks like. And every few moments, a big concrete lorry drives past me, making sure that these builders have what they need, concrete. And as it happens, here comes another. Where are you, Neil?
I'm on a concrete bridge looking at a concrete dam that's holding back a lake above my valley in Western Canada. Concrete and its key ingredient, cement, are, well, everywhere.
Concrete is the material of the modern world.
What does it mean for climate change?
It means a lot. Talking about just cement, that's about 8%, maybe even up to 10% of the global CO2 emissions every year in one material. This is how important cement is.
More important than aviation or shipping. And that 8 to 10% number may rise. Experts think that we could be adding a New York City every 34 days for the next 40 years.
So our climate question is, must we cast our future in concrete? Concrete might not be the first thing you think of when it comes to climate change, so we're going to need a guide, someone who's advised governments and companies on infrastructure sustainability. Someone like
Arpad Horvat, Professor of Civil and Environmental Engineering at the University of California, Berkeley.
I read that concrete is the second most used material on Earth, only after water. That is just absolutely staggering.
Exactly. Concrete surprises most people, even the people who work on it. Look out the window. Everything is concrete. We live in a sea of concrete. We wouldn't have an energy system. We wouldn't have data centers. We wouldn't have the internet without concrete.
We wouldn't have one of the best preserved ancient Roman buildings either, the Pantheon. I'm amazed we've been using concrete for so long. Even the ancient Egyptians used a form of it to make the pyramids. And there was me, all along, thinking it was a modern material.
It is easy to manufacture. It is very economical, very affordable. And people know how to construct with it. So all of these qualities make it really the civil engineering material of choice.
How much concrete do we use today?
We make about 25 to 30 billion tons a year globally, and that's with a B.
25 to 30 billion tons. If, like me, you have trouble picturing that, try this. Imagine an African elephant. Now imagine 6 billion of them. That's how much concrete we're producing a year.
Is that trajectory expected to increase in the future?
It is expected to continue, but we sure hope that we can do something about slowing it down.
Let's head to China, a country that's king of concrete.
I'm Sophia Yan. I'm the China correspondent for The Telegraph.
Where are you?
I am sitting in Daxing Airport. This is in Beijing, in the southern outskirts of the city. This place opened in September 2019, and it's so large it actually spills into the neighboring province of Hebei. I'm just going to rattle off a bunch of numbers.
Okay.
Well, Daxing Airport cost $17 billion US and nearly 5 years to build. Yeah. Massive structure of concrete, steel, and glass. I think massive is maybe not even the right word to describe it. It's massive. In terms of area, it's about 18 square miles. That's a little bit bigger than all of Cambridge.
Cambridge is your stomping grounds, isn't it, Greer?
Yeah, it is. And this is such a random comparison. I love it. It takes me about 20 minutes to cycle from one side to the other. So that gives you a sense of how big this airport is and the mind-boggling amounts of concrete that would have been needed to make it.
Well, China is actually the world's biggest producer of cement and uses almost half of the world's concrete. Some people dub China as the world's concrete superpower. And since 2003, China has poured more cement every 2 years than the US did during the entire 20th century.
I mean, that number is so... I've read that statistic. It just blows my mind. What are they doing with it?
You think about this country of 1.4 billion people. Cement is what has turned cities like Shenzhen, like Beijing, from sprawling villages, rice paddies, farmland, into giant urban centers with millions of people.
Last month, Xi Jinping said China had ended extreme poverty. What role has concrete played in lifting people out of poverty?
Well, infrastructure investment has always been very important in terms of supporting the Chinese economy, but it's also meant that a lot of unnecessary building has gone on in favor of growth. So China's littered with what are often dubbed ghost cities, these giant residential and commercial developments that went up in efforts to boost the economy, but were never fully realized because there just simply wasn't enough of a need for more homes and shops and businesses.
So what is it about cement that's so bad for the climate?
We've been talking to Professor Karen Scrivener about this. She runs a construction materials lab at École Polytechnique Fédérale in Lausanne, in Switzerland.
She's a leading concrete chemist and can explain how mixing a bit of sand, gravel and limestone produces so much of one particular planet-warming gas, carbon dioxide or CO2.
There's two aspects. I mean, of course, you have to heat these materials up to quite a high temperature, 1450 degrees Celsius, but that heating only accounts for something like 40% of the CO2 emissions. The other 60% comes from the breakdown of limestone.
Limestone is a key ingredient in cement, and cement is the stuff that binds concrete together.
So limestone is calcium carbonate, and when you heat it up to produce cement, it decomposes into calcium oxide and CO2.
You don't need to worry too much about carbonate and oxide. You just need to know that when you make cement, you have to heat up limestone, and this releases carbon dioxide.
And that represents something like 60% of the CO2 emissions.
Right. But you're saying that emissions are essentially baked into the production process, and therefore not easy, presumably, to reduce.
Well, exactly, because if you talk about stuff from heating up, eventually you could replace this with some form of renewable energy. But when you talk about the CO2 from this chemical breakdown of calcium carbonate, there's nothing you can do about that.
Not quite nothing, but we'll get to that in a minute, because cement is a real sticking point here. If it were a country, it would be the third largest emitter in the world after China and the US.
If we found a way to reduce the emissions from cement by even a third, that would mean a significant savings in CO2 emissions in the entire world.
Given its fundamental role in modern society, what can be done to reduce the carbon emissions from concrete?
That is literally the billion-ton and hundreds of billions of dollars worth of question.
A question some have been trying to answer. Some have made sure their cement kiln is running as efficiently as possible. Others, as Karen says, have switched to renewable energy. But this only gets us part of the way. It doesn't tackle the problem of cement in and of itself.
The replacement of cement is a real opportunity and a very big one. So we can't entirely substitute cement as we know it, but we can take parts of it out and substitute it with something.
Things with amazing names like blast furnace slag and fly ash. Both are byproducts. Slag is from steel production, fly ash is from burning coal.
And fly ash won't be around for much longer if we're hoping to phase out coal. There are companies that are producing so-called eco-cement, but it often has to be made in special labs, and it's expensive. So that's not really practical and can't be made by everyone, everywhere.
Remember, concrete is made locally, just like bread is, just like water is purified locally. Concrete cannot be exported. It has to come from within about a 20-kilometer radius.
This local angle is what Karen Scrivener's been concentrating on.
We made really an analysis of everything else that was existing on Earth, and the only material that's really available in the kind of quantities we need are clays. And then we can take these clays, not all clays, but a vast majority of clays, and we can heat them up, this time at a much lower temperature, only to like 800, which is similar to a pizza oven. And then we get a very reactive material which can react with the cement. And with this combination of calcined clay and limestone, we can substitute 50% cement.
Is this just something you've done in a lab? Are there buildings going up where we could see this?
So we started working in India, which of course has a very important potential in terms of using cement. It's the second biggest producer today. And with our team in India, we did a lot more trials, a lot more productions, built more houses. But the big stakes is really to convince the industry to do this, because it's no good sort of, some little team of people producing a few tons here and there. If this is going to have an impact on world CO2, it has to be taken up worldwide by the industry.
At one end of the industry are scientists like Karen, at the other end are the builders. Somewhere in the middle of the production chain are the people who design the buildings.
My name is Anupama Kundu. I'm an architect and a professor of architecture at the Potsdam School of Architecture.
That's in Berlin. She's a prize winner, and her own home back in India has featured in a swishy TV architecture series. But she also designs more affordable options, including homes for the homeless. Everything she does aims to have a low environmental impact.
As well as using eco-cements when she can, Annie Palmer has been trying to use less of the stuff too.
So, when you break your hand and you get a plaster cast, and they use a lot of gauze so that the plaster doesn't break. It's just very thin mesh, right?
Yeah, I know what you mean.
That's the principle. Ferrocement is very different from reinforced cement concrete in the sense that it contains within it steel mesh or alternative meshes. We've done work with glass fiber, for example, and non-rusting meshes.
And you said you can make a big saving with this ferrocement by adding this mesh. How much of a saving could you make?
It really depends on the application, But if you don't look at economic savings alone, but look at the holistic, if you use that much less material, maybe 20% or 30%, it's a lot.
If we took all of these various steps and actions, substitute cement for something that's less harmful, optimize cement production and use, increase efficiency in construction, increase efficiency in design, we might be able to bring down the CO2 emissions associated with concrete by about 50%.
That's pretty sizable. Are we seeing that?
Yes, we are seeing it. We are seeing individual actions by individual companies and individual stakeholders. What we are not yet seeing is all of these actions being implemented everywhere at the same time. And that will need to start happening.
What do you think is stopping us from taking faster action?
We're dealing with a very distributed industry here. It's not a couple of large players. It's not a couple of people we need to convince. It is hundreds of thousands of people around the world that would need to change their action. So the scale of the problem is very large and the scale of the solution is very complex. But what we are missing right now is still a critical determination to get everything done.
The problem of our times is that people started using standardized products so routinely that I think humans started behaving standardized as if they themselves are robotic almost, And I think we don't sit back and question our habits and if they serve us or not. I don't think people are just trying to waste material and consume because they're greedy. I think there's a kind of laziness. I did a building called Sauchu Multipurpose Hall, in which it's an entirely cement concrete building. And I did 3 different designs to bring it down from 125 cubic meters of concrete to 75 cubic meters. Now, this meant a lot more work for me and for my engineers. We've done several versions of this design, and that takes time.
So design smarter.
Design smarter, and also, on the other hand, stop the stupidities.
Whilst architects, engineers and scientists all have a role to play here, so does the state.
What's China doing to bring down emissions from concrete?
Well, there's a lot of work in terms of trying to set different targets to simply produce less and to use less. But it's hard to wean off this stuff. It's a cheap construction material, and China doesn't really have plans to slow down on building. Between now and 2030, there are estimates that China will put up half of all buildings expected to be constructed globally. So China knows that it needs to find some sort of middle ground. There is some effort to figure out a solution. And a few years back, in 2018, there was a pilot carbon capture project that was launched to grab, separate, and purify the emissions from a cement kiln run by China's largest cement company. It's meant to capture about 50,000 tons of carbon dioxide a year, but that's one project for one cement kiln in a country that's massive.
More than 5,000 members of China's political elite are gathering in Beijing for the biggest event on the political calendar, which is set to highlight
the all-important meeting to finalise the 5-year plan. Many had hoped climate change would be high on the agenda because President Xi Jinping made a big announcement last September. He pledged China would go carbon neutral by 2060 and hit peak emissions in the next decade.
But it's not clear that the new 5-year plan will do that.
In recent years, China has aimed to produce less steel, cement, aluminum, but in 2020, China actually produced more of those than it did in the previous year, in 2019. That's also related to trying to boost the COVID-ravaged economy. So experts say that eventually China will need to set and stick to some very strict targets. But setting that target is just one step in the right direction. Then you need compliance, and you need that for the long term.
So China's set to use more concrete even as it knows it needs to bring down its emissions. But China's hardly alone. We're all doing it. Why?
What's holding the industry back from challenging the status quo?
I don't know, because we are intelligent people, and if we do things after knowing that it's bad, and I think a lot of us are doing it today, and that's why the world is where it is. 30 years ago, I thought we didn't have the knowledge to be more sustainable. Now I know we had the knowledge. The problem is we know it and we still don't do it. And this is worrying because it comes down to very deep questions about who we are and why do we do things at all. And that's a very, very different level of question.
And I mean, you talk about decisions, but something that strikes me about the industry that you work in is there are decisions at every stage here, from, you designing the building all the way through to the project management and the builders themselves who are making it. So I imagine it must be quite difficult to see where the responsibility lies for reducing the emissions associated with construction and infrastructure.
I think the responsibility lies in all of us. And I think if you take it as a responsibility and a burden, then people feel blamed and they feel they are not good enough, and then they flee, from that pressure. I think one should unleash some enthusiasm here, instead. That's the way I've approached it. I wake up in the morning and I want to take my most exciting idea and develop it. Not because I feel guilty or worried about, I'm not informed by the fear that the world will end and things like that, I'm excited to be more conscious.
Conscious, but not do away with concrete entirely. All our guests this week recognise that that's not possible. Here's Karen the chemist again.
Yeah, and I think a lot of people think that it can be replaced by something else. But as I said, it makes up more than all other materials put together. If we take something like wood, which is often trumpeted as a solution, we're actually cutting down more forest than we're planting today. And if we were going to replace even 1/4 of concrete with wood, we'd have to plant new sustainable forests 1.5 times the size of India. And I think it doesn't take much to realize that that's just not feasible on the planet today.
So in other words, then we have to then crack this concrete problem of its emissions.
Yeah. And, it really is the best solution. It's the best solution in terms of the environmental impact. Also, in terms of building healthy structures for people. I mean, in many countries around the world, people dream of having a concrete house with a concrete floor so they don't have to live on an earth floor. We've forgotten what an impact concrete has made in terms of healthier buildings, more sanitary buildings.
Do you think our future has to be cast in concrete?
Excellent question. Our future needs to be cognizant to use the lowest carbon solutions, whether that comes from concrete or an alternative material, whether that comes from foregoing demand for materials, whether that comes from foregoing consumption. These are the large questions.
Concrete is not just about what we build with, it's how we live our lives.
We want richer ones, healthier ones, and we want to avoid the worst effects of climate change.
Will we be able to substitute airport runways, which are currently made of nothing but concrete, with an alternative material? Probably not. But if that's the only application left to use concrete, I think we have the freedom to continue to use concrete because there's nothing better. We're not going to be able to substitute airport runways with wooden logs.
Doesn't sound like a good landing. Anyway, a bumpy landing.
Does not. But what is the largest question here? The larger question is, do we need runways? If we don't need runways, we don't need concrete. But then we are in a different domain.
Neil, what's caught your eye in climate news this week?
There's a really interesting story out of Japan. It's been 10 years, can you believe it, since Japan was hit by the largest earthquake in its history. It produced a tsunami, which killed 15,000 people, and the tsunami also knocked out the nuclear plant at Fukushima, which led to a meltdown that ranks among the worst nuclear disasters anywhere ever.
10 years, gosh.
It's amazing. I mean, the images have really stuck with me, actually, of people like running from this terrible wave and whatnot. Japan responded by shutting down all its nuclear plants, which was a big deal. They were providing 1/3 of Japan's electricity. Now, to date, a number of the plants have reopened, but their contribution to the power supply is only in the single digits. And the capacity has been replaced by fossil fuels, which makes it harder for Japan to hit its climate targets. The government wants to reopen the nuclear industry. It's desperate for more electricity. And, there they have sitting a fleet of plants ready to produce carbon-free power.
So?
Well, the public is totally against it. And the FT's put it really well. It says Japan can't live with nuclear power, and it can't manage without it.
This is something that's played out across the world, hasn't it? Germany shut down a lot of its power plants after the Fukushima disaster. But many argue that this is the only way that we're going to have reliable, low-carbon energy in the future. It's a really difficult and sticky situation.
Mm-hmm. What about you? What are you seeing?
Well, you know how we did a show just recently on a just transition, and we heard from that town, Craig, in Colorado, that was highly dependent on coal?
Of course.
Well, it turns out Colorado doesn't just have to worry about the carbon dioxide emissions from coal. New research out in the journal Nature Sustainability shows that the emissions from the state's legal cannabis farms are higher than its coal mines.
No.
Yeah. I mean, previous research has shown that just a couple of pounds of weed can have the same environmental impact as driving across America 7 times.
Wait, a couple of pounds of weed is the equivalent of driving across the US 7 times?
Yeah. And it's mainly because cannabis is grown indoors in these super energy intensive, climate controlled conditions. So lighting takes up about half of the energy. But they also have to use things like dehumidifiers to prevent mold. They flush the room with CO2 to promote growth. And then they have these fans to mimic a breeze. So all this would be fine if they were using renewable energy in Colorado. But in 2019, half of Colorado's electricity came from coal and a third from natural gas. So you can quickly start to see how the carbon emissions from cannabis way outweigh the carbon emissions from Colorado's coal mines.
Amazing. Absolutely amazing. I had no idea. That's it for this edition of The Climate Question. If you subscribe to the podcast, every episode will land right in your pocket. And if you can, leave us a review.
Recently, we asked you to get in touch with how you've reduced your carbon footprint, and we've had some really lovely responses. Amelia in China says that after hearing our show about the internet, she's reducing the amount of videos and music she streams. Hailing from the UK, Elizabeth wrote to us to tell us how she showers with a cold bucket of water. I think
No, thank you.
I think she must have listened to the episode where we showered together, Neil, and tried to save water, because she's got some advice for us in case we want to give her technique a go. To avoid cold water shock, she suggests that you start with your feet and work up.
I think I'll start with offsetting my carbon emissions elsewhere, to be honest. We love reading what you're up to, so please keep the emails coming. The address, theclimatequestion@bbc.com.
All that's left to say and do is tell you that the episode was produced by Alex Lewis with the help of researcher Zoe Gelber. Mixing was by Tom Brignall and the editor was Emma Rippon.
Hey, not done yet. You are clearly a discerning listener. Thank you for sticking with us. You may also be interested in this.
I'm Dessa, the host of Deeply Human, where we find out why you do the things you do.
Why do you fall for him or her?
What attracts one person to another? Why do you get déjà vu? And how does pain change the way that you perceive yourself?
There's a whole bunch of taboos around illness.
From the hidden power dynamics of the standing line to the technological advances that challenge our definitions of death. Join me for Deeply Human, a BBC World Service and American Public Media co-production with iHeartMedia. Just search for Deeply Human.